Right, morning, guys. I hope you're all well. Welcome to another session of computer architecture. I think, as discussed in our previous sessions, it's time we started working on exam prep just to ensure that we are all sorted as far as that particular assessment is concerned. Right. So, as we've mentioned before as well, the structure of the exam is still one and the same. I think you've already experienced the test as part and parcel of an assessment. Literally, what is happening in that regard is you will still have your generically incorporated questions like your multiple choice, match-based columns, and in some instances, you might also encounter true-false questions where you're supposed to identify which particular question there or contribution is false, and then obviously state the reason why. And then the other thing that you also encounter in some instances is fill in the blanks as far as these particular assessment questions would go. And naturally, you'll also have scenario-based or long-based questions as well that will contribute naturally to the entirety of the actual paper itself. So naturally, you've got a 2-hour paper that is going to be 120 marks. Or alternatively, you'll have a 3-hour paper, which is 180 marks. But your 120 mark papers are the ones that have been distributed for a while now. So my best bet is that your 120 mark question paper of the 2 hours is your default go-to. Naturally, you're given anything between 5 to about 15 minutes as far as reading time is concerned. So I think I normally advocate for you to ensure that you actually use the entirety of the time that you're given. So just quickly skim through the actual paper itself, get an understanding of what the paper is like, and obviously you will see or spot a couple of questions that you're more comfortable with in terms of answering. Just ensure that you probably obviously note these down, and then obviously as the exam starts, you possibly start tackling those questions in your answer book. All right. So obviously, if it's just for argument's sake, if it's the last question of the paper that you're actually comfortable with, maybe you might want to start making notes and then go back and work with the other questions that you're not too sure of as far as assessments there would go. So when it comes to answering, I think for me, I'm not really concerned in terms of the actual order per se. So, but what you obviously need to take into consideration is if you, for instance, want to start with section B, just ensure that you complete section B rather, in its entirety before you start moving on to a different section. So try and avoid the scenario where you literally answer the question in a haphazard fashion. So order for me, per se, like I mentioned just a couple of seconds ago, is not really important, but just ensure that if you start with a specific question or start with a specific section, ensure that you complete that section and question first before you move on to something else. So for instance, let's assume you want to start with section B of your particular exam or assessment there, and you decide that probably question 3 is the one you're most comfortable with instead of in terms of starting. Go ahead and start with that question, but complete the question in its entirety. So for instance, if question 3 has 4 particular parts, don't go and complete first 2 parts, then go back to question number 2, then come back and complete question number 3. Just ensure that there's some kind of order, obviously, in the way in which you answer these particular questions, just to avoid discrepancies in that regard. So you've got enough time. If we want to look at it from a different point of view, I mean, 2 hours, honestly, you've got enough time for your actual paper. And then again, with the 5 to 15 minutes that I've just mentioned that you're normally given to read through the paper before you start it, just makes it slightly simpler or easier if you're obviously prepared, to ensure that you get the gist of what is happening as far as that particular paper would go. So when it comes to material, I think we've literally covered everything that is relevant there. I think I did advise for you to look through certain content associated with mobile computing there. I think that is literally the last distinctive section that is relevant as far as assessments would go. There are a few types of questions that come out as far as that particular chapter is concerned. So I think we'll look at some of them as far as today's session would go as well, and then naturally entertain any questions from the floor. So I think we've got one more session left, if I'm not mistaken. Correct me if I'm wrong there. We've got another session on the 19th, right? Which is literally next Saturday. So we also have, I think it's an online session as well. So we will look at a couple of questions, but I advocate for you to, at least during the course of the week, if you can look through the past papers that are there on your library portal, and then probably plug in content that you're not too comfortable with. Possibly send me a mail beforehand, before the actual lecture next week, so that we can look through those questions in that particular session, just to ensure that we're all on the same page. So have a quick look at these. So literally relevant content would obviously come from past test as well as exam papers. So just don't look at past exam papers for basic guidance. You'll find that your test papers as well will have certain questions that are still relevant as far as the actual exam would go. So what you're actually looking at in terms of your prep is not just the past exam paper, but also including your past, excuse me, your past test papers. So it's imperative for you to obviously have a quick look at that pool of questions. I think you've got papers from 2015 all the way back from 2015 up until 2020, naturally. So look through that content from your library portal. And again, like I was saying, should you obviously find any content or questions that you are not too comfortable or familiar with, if you want to look at it from a different point of view, pop me a mail during the course of the week, so then we can just have a pool of questions as well that we will look at in our last session, just to ensure that we are adequately prepared for the upcoming assessment there. Like we've mentioned a couple of times over, your pass mark is naturally 50%, and naturally, should you not, so remember, you're going to have your actual test assignment ICE marks there as part of your CAS mark. That will then obviously enable you to qualify to write the actual exam itself, and then those marks are naturally combined to give you the overall mark as far as the actual module there is concerned. So your pass mark, like I was just saying a couple of seconds ago, is going to be 50%. Should you not hit that mark and you are between 40 and 48%, then naturally you would qualify for a supplementary as far as assessments would go. But naturally that supplementary is going to be capped at 50%, right? So that is something that you also need to take into consideration. And then unfortunately, should you not then make the supplementary, or should you not pass the supplementary, then it would unfortunately mean that you will need to repeat the module. So let's take that into consideration there when it comes to our prep. So as far as today goes, I think we've got a couple of questions that you might find relevant and naturally interesting. So let's see if we can quickly, let's see if I can quickly share my screen again here. And then we can start getting into these questions. What do we have here? All right, so this is from the 2018 paper. As far as assessments would go, I think, like I said before, you'll get the similarities in terms of questioning techniques or the format of the actual paper itself. So naturally, you've got multiple choice, match columns, the missing words, true, false in certain instances, and the long-based questions or scenario-based questions I was mentioning a couple of moments ago. So we've got one here that is discussing, or that is asking you what is happening as far as the whole concept of securing a wireless network. So this is also all part and parcel of the portable computing section. And if you obviously take it into cognizance that when you're using a portable device, more often than not, you're not discussing connectivity to a bounded network. Since it's a portable device, obviously wireless network connectivity is what is your natural default go-to. As far as network connectivity would go there. So you'll normally have what they call a wireless network that is also known as your SSID, which literally refers to the actual wireless network name associated with your portable machining mechanisms there. So obviously there are ways and means to secure your particular wireless networks. I think it's more imperative in that regard because it's a wireless network there. There is a connection, but there's no physical link between devices. So naturally, quite easy for individuals to kind of intercept and log on to these wireless networks. So normally what you incorporate is your credentials, your generic username and password configurations there. So your actual network will have a name. And like I said before, that name is associated with what they call an SSID or service set identifier. Right. So that particular network name is normally accessible to or visible to everyone within the same locality or vicinity as far as that network range is concerned. But if someone wants to obviously access or log on to that network, they typically need to incorporate a network password or key, if you want to look at it from a different point of view. So there are ways and means to try and secure your networks there by incorporating, obviously, more stringent passwords or more complex passwords. But what type of architecture that you're using would naturally dictate the type of password per se that you can literally incorporate. So in this particular instance, as far as that particular multiple choice question there is concerned, we've got NTFS, WEP, WAP, WPA2, and then FAT 32. So obviously the first option there, NTFS, is the file system. So that is naturally out as far as your distinctive security there would go. The third question, option rather, is WAP, which is short for wireless access point. Again, that is a connectivity from a physical point of view per se, or a platform or an architecture that avails for a network connectivity to that wireless network. Doesn't really talk to security in this particular regard. And then the last option there, which is E, is also a file system, file allocation table, the 32-bit version that is there. Again, that is naturally out. So that leaves us with options B and D. All right. So WEP is short for wired equivalent privacy. So I think let me see if I can type on this. Okay, there we go. So we can then, so this one here is short for wired equivalent privacy. So this is a type of architecture that was developed, I think, back in 1999. That was also, it mimics bounded architectures in terms of basic security. So you've got very entry-level type of encryption associated with your WEP when it comes to securing your wireless networks. It's not as robust as you'd want it to be. So it's naturally not preferred when you're looking at securing your wireless networks because of basic incapabilities associated with its distinctive making. So it's one option that you can use in terms of securing your particular wireless network. But again, like we mentioned before, it's not as robust as you'd want it to be. And then WPA2 is short for Wi-Fi protected access. access. I think you got that spelling right. So that's the second version there that you've got. So Wi-Fi protected access is naturally what WPA is all about, and it's a more robust type of security. It's a wireless security platform when it comes to your wireless networks. Why? Because it provides for or it uses better encryption architectures as far as configurations would go. So normally you've got WPA, WPA2, and WPA3. In terms of the different versions that are there, literally what you're looking at is just an enhancement in terms of what is happening as far as the security there would go. So naturally, WPA3 if would be your the best bet in terms of configuration. But in the options that we've got there, we've got WPA2 incorporated as far as your configurations there is concerned. All right, so it's a lot stronger when it comes to security and basically easier to configure when you compare it to prior options that were there. So obviously the main difference is that your WPA2 uses what they call an advanced encryption standard that makes your environments naturally more secure as far as your wireless configurations there would typically go. So your WPA conventions there are your default go-to, but I think if you want to be more specific in this particular regard, what you're actually looking at here, WPA2 is what you're distinctively literally going for. All right, so that stands for WPA2. So your option D there, when it comes to your wireless routers, there becomes our default go-to as far as that particular question there is concerned. All right, so that does that in terms of that particular question. I think the others we've looked at before as far as that particular paper would go. I think there's also been another clip that has been uploaded that looks at discussing certain questions as far as that paper would go. And then when you look at another set of multiple choice questions here for the I think this is a 2016 paper, yes. So with this, you're looking at security again. I think we've discussed the whole concept of malware or malicious software and the different types that exist, and obviously how they adversely affect systems at large. So you've got question 1.7 there that is looking at the whole concept of a certain individual that has downloaded a game off the net, installed that particular game, and then obviously as soon as they started working on the game, a BSOD was gotten as far as this particular system is concerned. So remember, blue screen of death normally is associated with memory, any system issues. Normally that point to your memory. Normally that point to your actual storage, and in some instances even CPU configurations as far as setups would go. So it just naturally indicates an actual problem with the system. Normally, these particular BSODs are naturally, well, they naturally disappear just by a natural reboot of the system. But in some more, in some intricate cases, what you're now looking at is probably replacing certain hardware components like your RAM, your hard drive, and so on, or alternatively looking at reinstallation of certain softwares, in some instances, the operating system at large. So upon rebooting this particular machine to try and obviously fix that error, this particular individual discovered that the My Documents folder on his machine has been distinctively erased. So you've got a couple of options that are there as far as your mechanism would go. And I think we've mentioned before that normally when you look at malware that literally pretends to be something that is not, you're distinctively discussing what they call a Trojan horse. Spyware is out there because normally what that particular type of software or malware rather is doing is just checking your keystrokes, what it is that you're doing on your machine, what sites you're accessing, what apps you're using, who you're communicating with at large. But when it comes to software that is actually mimicking legit software and pretends to be something that is not, naturally what you're looking at is what they call a Trojan horse. So in this particular instance, your default go-to there, as far as your particular option there is concerned, would obviously be your Trojan horse in this particular instance. So just remember that your Trojan horse's main issue there, per se, is the fact that you're distinctively looking at the whole concept of something that mimics legit software. Normally, in some instances, you might even find that it attaches itself to legitimate software. So, for instance, you install an application package, and your particular Trojan horse there attaches itself to that particular package. Anytime that you open the package or work within that package, it's obviously adversely affecting your system in the background as far as your usage there would go. So another security question there, 1.8, we've got an individual that is distinctively dressed up as a fake security guard that matches the uniform of the company, walked in with legitimate employees in an attempt to gain access to company resources. What kind of attack is this? So you've got administrative access, and then we've always mentioned that with admin access, remember, you're looking at it from a software point of view or from a system point of view. So you look at it from a different perspective, where you're using admin rights to do something that you're not supposed to, as far as your specific system would go, or network. It all depends. So naturally, you normally find that your admin accounts have got all rights associated with what the system is all about. So these particular rights, naturally, if they're given to the incorrect individual, or if they're used incorrectly, or if they're used in an adverse fashion, naturally can detrimentally affect everything. Confidentiality of stored content when it comes to personal data, and obviously what it is that you can do as well on the system. It's something that can be quite problematic when it comes to your systems or networks at large. And then naturally, data destruction there, it can be inadvertent or on purpose. So it's naturally looking at deleting data or distinctively corrupting data, if you're looking at it from a different point of view. So that obviously is, again, within the system setup. That leaves us with spoofing, tailgating, and none of the above. Now, remember, when you look at a spoof, you're pretending to be something that you're not, but again, this is within a system environment. So naturally, you can spoof an IP address, you can spoof a MAC address, you can spoof an actual email address as distinctive examples there. So that would then enable you to incorporate a gadget, whether it be an actual wireless access point, a router, a computer system, you name it, within a network to literally act as if it's supposed to be part of that network by spoofing the IP, MAC, or distinctively an email address, or even a web address is something that can be distinctively spoofed or mimicked. But in essence here, what we're looking at an individual who's physically gained access to a distinctive environment. And our default go-to there, as far as the actual options that we've got, is tailgating. So this particular individual has moved into a specific premises or locality with legitimate individuals that are supposed to be in that premises or locality, obviously walking with them to typically mimic him being a legitimate individual that is also supposed to be part and parcel of that environment. So what you're actually looking at in this regard is tailgating. And I think we've discussed this before, that if you look at most banks out there, they try and limit or literally avoid the whole concept of tailgating by ensuring that they've got what they call a man trap, where when you're entering a bank or a banking premises or banking hall, for argument's sake, you've got a specific door on the outside. and naturally you're literally given a green light to enter that particular premises. So the moment you enter that distinctive space or that man trap we were talking about, the door behind you closes. And once it successfully closes and obviously senses or identifies as only one individual within that man trap or space, then the other door opens to avail you access to your specific banking premises or banking hall or bank, if you look at it from a different point of view. That's a typical example of what a man trap is all about, and its main purpose is to distinctively curb or naturally do away with tailgating to avoid individuals, obviously, or to literally make sure that individuals are secure as far as that specific environment they would go. So in this particular type of question there, what we are distinctively looking at is tailgating as a distinctive option. And then with 1.9 for this particular question, we've got, or this particular paper, we've got, I think we've discussed your command line before, right? And we mentioned that command line is just another way of literally interfacing or engaging with your system, as compared to what we are normally associated with, which is your graphical user interface, slightly more user-friendly as opposed to command line. Why? Because obviously with command line, what you need to typically do is understand the environment and know exactly what's happening with the syntax of the commands that you are literally supposed to be running in that regard. So when you look at it from this particular point of view, you've got, they've mentioned that which is the correct path associated with the file name. So we've mentioned that backslash configurations or backslash representations are normally associated with your locations within your system, and then your / are normally used with options. Or what they call switches when you're actually running or typing or working with commands within your environment. So we've got a scenario here where they've mentioned which is the correct path for a file named yoda.txt that is in. So that's remember that file extension just tells us that it's a text file that's normally used within the Notepad program. File extensions are also important in terms of understanding exactly which programs are used to work with that file or to create that file, and ultimately also enables us to know what type of file that we're distinctively working with. So this particular text file is on the C drive that is in a directory called Jedi, which is in a directory called Rebels. All right, so that's the setup that we've got. So we've got the C drive, which is obviously our main drive, which is the associated with your hard drive, as far as associated with the partition, as far as your particular hard drive is concerned. Within that C drive, we've got an actual directory called Jedi, which is in a directory called Rebels. So which means that if you're looking at a specific hierarchy in this particular instance, what you are typically getting there is that your C drive becomes your root. So if you go back, let's see if we can actually look at it from a diagrammatic point of view here. Right, so they've mentioned here that we've got your C drive. So remember, this is the actual hierarchy that is associated with your specific environments there, right? So we've got the C drive. In that C drive, they've mentioned that your particular file, which is called Yoda, is in a folder known as Jedi that is in a folder called Rebels. So it means that your Rebels becomes your first subfolder or folder. Maybe let's try to put it that way. I think this becomes your folder. And then there's a subfolder within Rebels that is called Jedi. All right, so that's our subfolder there. And then in that Jedi folder, we now have the Yoda .txt. Oopsie. .txt there. So that's the kind of setup that we've got as far as our distinctive hierarchy would go. So our C drive is normally associated with the term, that's our root, right? And then you've got a folder and within that root drive there, which is your rebels. And then within that rebels, you've got a subfolder that is there. And then naturally, you've got the particular a file that we've got incorporated. So if you want now to look at it from a path point of view, we've got a C drive there, right? That we've got a folder called rebels. All right. And then in that rebels folder, we've got a subfolder called Jedi. Jedi. And then in that Jedi folder, we've got Yoda .txt. So that's the actual path that we've got as far as our particular setup there is concerned. All right, so just I think with these questions, again, it becomes quite interesting, because if you don't read it correctly, like I've been mentioning before, it can distinctively derail you as far as specific content there is concerned. So always take your time there to read these particular questions accordingly, because it's very easy for you to plug in none of the above in certain instances, or it's very easy for you to plug in a different answer there, having not read the actual question accordingly. So if you look at what we've got, if you look at option A, right, as far as your specific setup would go, obviously that particular option is incorrect, right? Same difference would go with option D, just for you to look at a basic discussion here. They've included the root, right? But remember, root already identifies as the C drive. So your root drive is actual hard drives or partition that you've got. So for instance, even if we're working with a drive D, for instance, or drive E or drive F, the list will go on and on. What you're actually discussing in that regard is that letter or that drive letter represents the root already. So you will not then incorporate C then root, because the moment you mention the C drive or the D drive or the E drive, that particular drive letter is representing the root. And then from the root, you've got your folders, your subfolders, and your files. So in this particular instance, the appropriate answer for us there is going to be C, because we've got the actual C drive. We've got the distinctive rebels there as our folder. Then we've got Jedi as our subfolder, and then you've got Yoda there. So if you read the question again, we've got a file that is on the C drive that is in a directory called Jedi. So automatically you've got the file and Jedi there. It should be one and within the same distinctive concession there, or sequence, or with a series, whichever way you look at it, because we already know that Jedi is the folder that has the file that is called Yoda, right? But on the other hand, that particular folder is within another folder called Rebels, which is in your root directory. So our default go-to there, as far as your particular answer there is concerned, is going to be the C option as far as that particular question there goes. And then the last of the multiple choice for this particular paper that I wanted to look at is also focusing on your command line. So again, with the command line, like we've mentioned before, you've got a list of options that are there, right? Or a list of commands that are commonly used. And I think what makes it easier is that with these commands within this particular type of OS interface, you've got descriptions of what these particular commands do. And you can also look at the syntax, which is also known as the grammar. I think we've looked at this before when we were discussing command line as far as your specific environments would go. So we've got an individual here that has got a file that they want to rename from start.bat to hammer.bat. And then they've got a list of commands there that you're supposed to be using in that regard. So again, if you were to look at what we've got, First of all, you're renaming start to, right? So it means that whichever set of commands that we've got there, our start.bat should be the one that is incorporated first, and then the hammer.bat, which is obviously short for batch files there, is the one that's supposed to be incorporated second. So it means that options B and options C there could be our default go-tos. But remember, it's very important to understand that what does the /s actually do for us? Do we actually have that when it comes to a rename, the rename command? Is that switch actually there? And what does it actually represent as far as your specific setups would go? So if you want to look at this, obviously, in this particular instance, our answer should be B there. But let's look at it from command line point of view so that we are all sorted and comfortable as far as this particular setup there is concerned. So ultimately, let's see if we can, let me see if I can display screen here. 2 seconds. Okay, so there's our command prompt. So we want to look at obviously the different options that are there. And remember, like I've mentioned before, should you not know what's happening with your commands there, or if you want to distinctively display a list of commands, we've mentioned before that what you need to be doing is typing in the help command there or option. In some instances, the question mark is doable, but then that would obviously be dependent on the actual version of your DOS there, or the actual version of the command line that you're using. So we're going to type out help, hit enter, and I think from the list that we've got, as you can see, we've got if you want to rename, we've got REN. That literally looks at obviously renaming files. So we've got that. Right, and let's see if we can actually run it from there. All right, so we've got these two options that you've got as far as renaming files is concerned. So you can either use REN or rename, right, as distinctive commands that are there to rename a file or a set of files, whichever way you want to look at it. So if we look at REN, all right, so here, if you want to then look at REN there, we're not so certain what it looks like in terms of syntax. We're just going to hit our / question mark and hit enter. And then it will display for both rename as well as your REN. All right. So you've got the drive, you've got the path file name 1 to file name 2, and then it's the same syntax. The only thing that changes is the actual name there. So from rename to REN, but otherwise the actual syntax or the rest of that particular command remains the same. So obviously, as you can see, there are no switches are used with the rename command here. All right. So ultimately, it would then mean either we're going to go and type out rename. So in this particular instance, as far as your paper there is literally concerned, they haven't mentioned the actual drive there, but for argument's sake here, should we be in that actual folder that has the rename or that has the start and BAT? What we're actually going to type out is rename start dot BAT to hammer dot BAT. All right. Or alternatively, what you can do is actually type out rename there. All right, so that's the actual syntax of the command that we're looking at in this particular regard. So if you want to run this, probably let's look at it from a different point of view. Let's go to a desktop here and probably create a file or a folder. Do we have our desktop directly here just for us to see exactly? Okay, so there we go. So we're going to create, or rather, let's make a directory called example. enter, and then we've got our folder incorporated there. So I want to create, let's see if we can quickly create a file there. And then we can give us 2 seconds here. So let's change this to our example. Right, so this, we want to create files in here that we can then, or throw in files in here that we can then distinctively rename accordingly. So let's, let me just take a shortcut to this. Quickly take a shortcut. Give me 2 seconds. Yeah. All right, so I've just taken a shortcut and created it in your GUI here. All right. Okay, so there we go. Right, so if you run the dir command, right, it will show us. So we've got a bat.txt. Actually, I was supposed to remove that txt there because that remains as a text file. So let's see what we can do quickly here. Where is this? All right. Okay, sorted. So there we go. All right, so let's run that again quickly. dir command, right. So we've got a batch file that is there, sorted. So I want to rename this to hammer.bat, right? So we're going to go and type out ren or rename, right? So any one of the two. So if you type out ren or rename, is one and the same thing. So I think one of the options that we got there is actually ren. So we want to rename start.bat. We want to rename it to hammer.bat, right? We hit enter there. We go back to the same a prompt that was there before. It obviously means that that particular command has been accepted and run appropriately by the system. If we then run our dir command, we should then not be able to see start, but instead we've got hammer.bat. So as you can see there, we now have hammer.bat as opposed to start.bat. So if we were to go back and type out ren, let's change our hammer.bat to start again. .bat. We hit enter there, and then instead of using ren, we now use rename. It's one and the same thing, right? So otherwise, maybe before we do that, let's just write. So as you can see, we've gone back to start.bat in this regard. So our start.bat is still there. So instead of typing out ren, we go rename. It should give you exactly one and the same thing. So we're going to rename the file start.bat to hammer. .bat, and obviously if you enter, what did I do? Oh, I put in so let's go back in there. Okay, so that's the correct type of command that you got. So start.bat. I put in an actual comma there. All right, so there, rename start.bat to hammer.bat, right? Hit enter, dir again. That hammer.bat has been changed. So ren or rename is one and the same thing. This particular command is not used with any particular type of switch, right? So if you were to go back and check our question paper, where were we? I think we were here. Right. Okay. So as far as this particular setup there is concerned, naturally, what that then would mean is our REN start.bat would be correct. So because we don't have an actual switch, so that means the rename one, if this didn't have the /s, then obviously that's a correct answer as well. But naturally, your rename doesn't have any particular switch there as an actual command. So our answer for this particular question is going to be that one there. All right, so that's imperative in that regard. And then I think we've got I think I had two more questions, or three, was it? Across the papers, yeah. I think this one, okay, so here's an example of the true false type of questioning that I was mentioning earlier on. It hasn't been there for a while, but there's a possibility that they'll bring this in. I think this was way back in, which paper was this? 2015, right? So again, it's imperative for us to look at these particular type of questions. I haven't been there for a while, like I just mentioned a couple of seconds ago, but it's still imperative for you to understand and remember, obviously being able to plug out what is false and distinctively give an actual reason. So here they've mentioned that you've got true false questions that are there, right? And then they've mentioned that select 5. So they've actually given you a heads up. I think probably this, depending on your scenario, this can actually make it a lot easier or literally more difficult for you. If they just mentioned identify, false, and state, then I guess the question becomes a bit more easier, I think, if you look at it from a different point of view. But the moment they mention that there are 5 of them that are there, can make it a bit problematic, because instead of finding 5, you probably might find 7, or instead of finding 5, you get 3. So it becomes a bit problematic in that regard. But again, like I said before, it can actually make it a lot easier, because should you discover that you've got a lot more or less than you're supposed to get, then it needs you to kind of recalibrate. So we've got central processing unit there that is responsible for performing all calculations that take place within the CPU, right? Or sorry, within the actual PC, right? As a statement. And if you look at it carefully, so here, I think in some instances you have to be quite pedantic about it, because if you look at this particular question, right, or this particular statement rather, it sounds right? Because remember, we've mentioned the fact that your central processing unit is the most important component in your machine, literally the brain of the machine, a bit of an overstatement like we always say, but it gives you an idea of what that component is responsible for. Everything that the machine does literally has to go through the CPU, or has to be given the go-ahead by the CPU, if you look at it from a different perspective. But now, if you break down the CPU into its appropriate components, we've mentioned that your CPU has your ALU, it's got your CU, you've got registers there, and obviously then there's that link between it and your main memory or your RAM, right? So ultimately, in general, your CPU is responsible for all processing, all right, as a complete unit. But the actual part that is responsible for calculations is a different component altogether, if you look at it from a different point of view. So let's look at it from this perspective. Let's see if I'm actually hitting on something here as far as this particular type of question here is concerned. So let's go back to our notes here and see if we can actually make sense of what I'm saying. So if you look at what I've just mentioned earlier on, so here, if you look at a diagrammatic representation, we've got something obviously along these lines, right? I think we've used this before, and then hopefully we don't run out of space there. So you've got your CPU as a combination of the CU and ALU, and then you've got your registers here, or your cache, or your SRAM. And then you've got your actual main memory, or RAM, right? Or DRAM, if you want to look at it from a different point of view. And obviously, there is a link through the address bus between the actual CPU and your RAM. I think we've had a diagram like this before, right? Where we've mentioned again that this particular unit here is your actual CPU. So that unit is the actual central processing unit, if you look at it. So obviously, depending on the literature that you'd use, content will be different, but the underlying architecture is one and the same thing. So your CU is your control unit there. Remember, it literally provides that particular link between the CPU and the rest of the machine, or it's responsible for ensuring that the commands are sent and received accordingly from the actual central processing unit to the rest of the machine or to other devices that are there. So its main purpose is just to ensure that commands are sent and received accordingly from devices or from the rest of the system. But remember, when you look at your instruction sets, these particular instruction sets have to be executed in a sequential and distinctively logical manner, because if there's no sequence or logic associated with the instruction sets, then ultimately the whole purpose of using the machine becomes null and void, right? So the appropriate component that is responsible for that is the ALU. And if you remember well, hoping that we've got enough space here, it stands for arithmetic logic unit, right? That's what the ALU literally stands for. And its main purpose is for all mathematical calculations, and obviously to ensure that there's some kind of sequence and logic associated with the way in which your instruction sets are literally executed. So that's the basic example of what that is all about. Obviously, you can go a bit more in depth with what that particular unit does and its making and obviously how it distinctively functions. But ultimately, the whole concept there is the arithmetic and the logic. So all calculations are distinctively undertaken by this component as opposed to the CPU at large, because the CPU's main purpose is to do with processing, but when it actually does processing, there is separate components within it that obviously avail for that literally give us the right result, right? So if you were to look, if you go back to this question here, all right, this particular contribution for me can literally be distinctively misplaced, because instead of having the CPU undertake all calculations, all right, you've got a component within the CPU that is obviously responsible for that. So ultimately here, I'm going to mention this is false. And obviously, why is the reason? Because what you're actually looking at, the right component there is your arithmetic logic unit. Right. So let's see. So we've got one day. All right. So fingers crossed. If we don't get more than 5 there, or less than, whichever way you look at it. So we've got a chipset, one or more discrete integrated circuits that support the CPU interfacing with all devices. Yes, that is true, because remember that chipset initially made up of the north and the actual south bridge. North responsible for RAM and graphics, but we've mentioned before that that is now kind of an obsolete type of analogy, really, or a description, because your north bridge functionality has now been plugged in directly into the CPU, right? So you've got integrated memory controllers, you've got integrated graphics, and then you've got the south bridge that is a lone entity now per se that defines the actual chipset at large, because it deals with input-output devices like your hard drives, every input-output device that you can think of, literally, inclusive of ports and so on. So your chipset initially subdivided into north and south. Its main purpose was obviously to assist connectivity between the machine and the rest of, or between the actual CPU and the rest of the machine, as far as configurations would go. So you've got that incorporated. Normally, we've mentioned now that Intel calls it the ICH or the PCH, and then AMD literally calls it just generically the chipset, but they're actually discussing the South Bridge at large there. So that statement is true for us. Device drivers, so we've mentioned device drivers, so that's C now. We've mentioned device drivers associated with our computing mechanism, right? And we've mentioned that a driver normally is a software package that is incorporated on a natural within an operating system platform or a specific operating system platform that enables interfacing with certain hardware. So if you're going to be using a printer, for argument's sake, on a Windows 10 platform, you'd obviously need to load a driver that is compatible with that particular, or the printer driver that is compatible with that particular operating system to enable your particular user to interface with the gadget or device through the operating system. But in certain instances, you find that when we discuss FireWire ports and USB ports, these particular drivers need to actually be installed before the actual component. Normally, you find that when you plug in a graphics card, you plug in the sound card, you will now need to, I think one of the actual questions that have been asked across these papers is the kind of installation procedure or steps associated with installing an expansion card, for argument's sake. And we've mentioned that the first thing, you need to be knowledgeable about that gadget or device. The second thing is obviously physical installation. After you physically install that component, then you need to load the driver to enable it to be used accordingly on operating system platform. And then the last thing you need to do is then verify, right? So with generic installations, your drivers are installed after physical installation. But when you look at USB and FireWire, those drivers are actually installed first. So C is also true. And then D there, once you've assessed the problem, this is the troubleshoot theory. So once you've assessed the problem with a user's machine, when troubleshooting, it is important to back up critical files before making any changes. And that is obviously true, because remember, we've mentioned before that once you've determined what the actual issue is, before you start working on the machine, you want to avoid a scenario where you incorporate fixes, but those fixes end up either corrupting or deleting data that was initially stored there. Sometimes you might find that some of these solutions require either a reinstallation of software or reinstallation of your operating system at large. What you want to do before anything is done really is to make sure that you back up data before you make those distinctive changes. So we've got another true statement that is there. And then with E, all right, we've got CPUs supporting 64-bit, can run compatible 64-bit operating systems and applications, but not 32-bit. All right, so remember, 64-bit is, in this particular instance, we are actually discussing the size or the width of the address bus. All right, so it's 64-bit, which naturally means that we can access much more than 4 gigs of RAM. We've discussed this before. On paper, we're actually looking at 16 exabytes of RAM, but obviously you've got limitations physically when you're now looking at motherboard compatibility and literally the actual making of the RAM modules, the actual making of the actual board, be it portable or desktop. And also looking at electronics generically, all right, if you want to look at it from a different point of view. But when you discuss 32-bit systems, you've got a limitation to 4 gigs of RAM, right? Now, remember, we've got a wider bus, which is 64-bit. It means that we can accommodate for 32-bit applications as well as the operating system, because we've got a wider bus. We've got twice the bus associated with 32-bit when it comes to configuration. So obviously, this particular statement here becomes false. Why? Because naturally, 64-bit is that 64-bit bus per se. If you look at it, can literally accommodate. Do I have the right spelling there? I think it's CCCM, right? Anyone can correct me on that one. Can accommodate the 32-bit, right? So at 64-bit bus can obviously accommodate, because it's twice. It's literally twice. It's twice the size, right? And in certain instances, you might find that some systems were distinctively designed specifically to work just with 32-bit configurations and so on and so on and so on. But obviously, from a general point of view, 32-bit can be accommodated for in that regard. So we've got the second false statement there. We've got 3 more to go. Let's see if we're on the right track there. When a PC starts running, that's if out of real RAM you have loaded, sorry, because you loaded too many programs, the system swaps programs from RAM to your hard drive, right? That's where virtual memory comes in. So whenever you're discussing a page file or whenever you're discussing virtual memory, literally, this is when some programs are temporarily moved to a small space on your hard drive to accommodate for physically installed RAM. And then obviously when that physically installed RAM gets more space or becomes free, if you want to look at it from a different point of view, then the programs or parts of programs that were initially loaded onto that small piece of hard drive space are sent back to your physically installed RAM. That whole process is known as disk thrashing. So we're not installing this on ROM, right? We are actually installing, sorry, you're not swapping to ROM, because remember, ROM is read-only memory, and it's normally an integrated circuit that's found within your system there that you can only access what is stored, but you can't literally change it. So naturally, you typically cannot use it as a generic storage device as far as your environments would go. So here, this statement is false again, and the reason why the statement is false is it's RAM to hard drive, right? Not ROM. So this is RAM to hard drive, not ROM. So we've got 3 there, right? And then a page file is a milder error that can be caused by memory issues, but not necessarily system RAM problem. But remember, again, we've just mentioned this. So I think the F and G are actually one and the same. A page file is associated with virtual memory. So obviously, the moment you get page file errors, I think you might have even written this in the previous test, right? A page fault is one of the issues that point to RAM problems, right? So this, again, is another false statement. Because remember, a page file is associated, associated with virtual memory, right? Associated with virtual memory. So obviously, virtual memory is all, when you're looking at virtual, it again, like I've just mentioned before, F and G are directly related there, right? So associated with virtual memory, and naturally, virtual memory is what literally assists physically installed RAM there, right? So we've got 4, right? And then we've got H, I, and J. So it means that one of these statements is incorrect, right? Or probably I'm the one who's incorrect, but let's see. So we've got CMOS stores programs already before even completing that statement. CMOS does not deal with any programs. CMOS deals with settings, right? So there's a relationship there. There's ROM, which is associated with storing BIOS or firmware, and then that firmware is read by, or we are literally to read what is in BIOS or to read your firmware, you are assisted by CMOS settings. So literally, if you want to look at it from a relationship point of view, CMOS enables you to read BIOS. BIOS is stored on ROM, right? So CMOS deals with settings, not programs. So BIOS is basic input-output system or services, right? So BIOS is what deals with programs or services, whichever way you look at it. And then CMOS deals with settings. So this one, without even completing that statement, this is automatically false now, because CMOS stores settings, right? Not programs. So we've got 5 already. Let's see. Overclocking works by changing the bus speed. Clock multiplies, yes, because remember, overclocking, you're pushing it you're pushing your system at large, specifically your central processing unit, but obviously your system at large, to higher speeds than set by the manufacturer, right? So this is intentionally running the system faster than it should. I think we mentioned before that it's neither here or there in terms of correctness, but normally you find find that a lot of individuals would rather buy slightly cheaper CPUs and then overclock them to run at a much higher speed. So that one is true. If the CMOS battery runs out of charge, all CMOS information stored, yes. All right, so remember, a missing battery or a dead battery would obviously jeopardize your CMOS settings there, all right, or literally does away with CMOS settings. Every time you boot your machine, you now need to reincorporate your settings, things like system time and date, and obviously in certain instances also ensuring that other hardware devices like your hard drive and optical drives, in certain instances, even RAM modules are identified accordingly there. All right, so that does that for that question. So we've got false arithmetic logic unit. That's 1, 2, 3, 4, and 5. False contributions. And again, like I mentioned before, normally with a false statement, you now need to either correct it or state the reason why it's incorrect. Okay, so that does that one. Do we still have enough time here? Let's see. Okay, I think what I'll have you do is if we can possibly look through. So this is the 2017 and the 20. So both 2017 papers. I think one was a supplementary exam here. So please look through these, and then I think the specific question I wanted for you to look at is question 5, which is to do with mirrored, duplexed, and striped volumes or drives when it comes to RAID, which is obviously a classic example of fault tolerance in that regard. I think here there's a typo there because it's not disk stripping but striping. So I think there's an extra P there. So look through that. What's happening with mirrored, duplexed, and striped drives when it comes to fault tolerance, and then we'll discuss it in our next session. And then also look at what's happening with security or authentication, or security at large, rather. So you're dealing with access control, software and hardware authentication, spam, and malware, anti-malware program. Just give an example of each associated with your security there. And then I think one of the other questions that I wanted to look at here for this other paper was to do with exactly. I think this deals with I think chapter number 1 again in the 10th edition of your prescribed textbook, which deals with the PC tech. All right. So how are they supposed to look at? So here, passwords are a big issue for techs. Explain the reason why it's not encouraged, obviously, to look at knowing or copying people's passwords when you're working on a system there. All right, so look through that particular question as well. And I think that should do it. So naturally this is another recorded session, so I'll upload it on the channel a little later on. And then you can always go through it again. But I think with we are then going to be looking at the other papers in our next session there, or the other sections in terms of the actual questions that will be relevant. So I strongly suggest, like I mentioned right at the beginning of the session, that please go through all these papers, and then should you have specific sections that you need reiterated or you need literally elucidated, let me know. Pop me a mail during the course of the week, and then we can obviously have a pool of questions that we can work on in next week's session to get us better prepared for the exam. All right, so I think that does that for us. Let me see if do we have any questions, contributions, and or concerns from anyone here. Feel free to type in chat there, post your question in chat. I'll just quickly unmute. Where do we have our mics? Yeah, right. So there we go. All right. So feel free to post a question in chat, okay. So I think there's something that's just come in. So exams, Heinrich, I think if I remember well, I think I know for the full-time students should be on the 2nd of July. So I'm assuming that you're obviously going to pop in again on the same at the same time. But I think this is something that we might need to literally confirm with the campus. But the full-time guys, which I think you wrote the test with the same group. So I think the dates they should be the same. So the 2nd of July, I think that's the default date, but we still need to confirm that. So I think maybe tentatively note down the 2nd of July, but it's still something that we'll need to confirm. I think there's been a 5th version of your PAS that has been posted onto your portal. So just have a quick look at that. If it still says TBC, then we'll just confirm. But if I'm not mistaken, I think the 2nd of July is the date of the actual test you're supposed to be, exam you're supposed to be writing. So tentatively note down the actual date there. And then you've mentioned the actual chapters. So this is learning units 1 all the way to 5. And if you look at this carefully, I think they've also given you a student guide, a module manual that is there. Let me see if I can quickly just run that by you again in terms of the actual chapters that are relevant from the 10th edition of your textbook here. Give me 2 seconds. So as far as the actual chapters would go from your 10th edition, the first chapter, the second one. So maybe let me just rather say it like this. I think the chapter number 1 all the way to chapter number 10. All right, so 1 to 10. And then you've got working with the command line, which is chapter 15. Then you've got your display technologies, chapter 17. We've got portable computing, 23, and then mobile devices, so 23, 24, 25, and then 26 and 27. I think there should be another chapter that deals with essential peripherals, yeah, which is chapter, yeah. So I think I mentioned the 1 to 10. So again, that's just to ensure that we're all on the same page there. So chapters 1 to 10 from the 10th edition. And then chapter number 15, chapter 17, 23 to 27. All right, so one more time, 1 to 10, 15, 17, and then 23 to 27. All right. I think that should be that should be the relevant there. I think building a PC, since we've done that physically, there is a building PC section as well that could assist. But I think the most important thing is looking at things like maintenance. So I think as some curveball kind of questions would come from chapter number 14 and chapter 14 and 11. All right, so curveball questions literally come from chapter 14 and 11. So you might want to add those as well, 14 and 11. But I think more of 14 than 11 because you've done that in the practical session there. Okay, so I think that answers you as well. There, happy there. That also answers that question. So I think that's sorted. Do we have any other questions, contributions, and/or concerns? Anyone? Questions, contributions, concerns from the floor? Anybody? computer building clips, yes, I think I can post those as well, just to get an understanding of what's happening. So we can, did I understand the question correctly? Do you want me to post these, or maybe before I start rambling there, with your question there, Happy, do you want me to post these clips, or what is it that you're mentioning here? Oh, okay, cool. Not a problem. I'll make a plan in that regard in terms of what's happening, and I'll also give you the relevant links in that regard. Okay. Right, sorted. So it looks like no other questions are coming through. Right. Anyone else with any contribution, any question, or any concern? Okay, so sorted. All right, thanks guys for attending. Keep smiling, stay safe, keep warm. We'll see you in the next session. Cheers.